All right, so how you name ionic compounds? Well, let me back up. Before you can begin to understand how you name ionic compounds, you need to understand valence electrons. You need to understand, all right, if I look at the periodic table, how do I know the number of valence electrons go with each element? And there's a pretty set, and so you've seen this slide before. I showed you this, think in Unit 3 or something, or Unit 1 maybe. Anyways, if you're an element in group 1, you have 1 valence electron. If you're in group 2, you have 2 valence electrons. The transition metals here, 3 through 12, they're kind of weird. They have different numbers of valence electrons. Group 3, they have 3, 4 have 4, 5 have 5, and so on. Okay? 8 valence electrons, that's when atoms are the most stable. So this is the goal here. Elements want to get 8. That's called the octet rule, where elements want 8 electrons. Okay? Because if you have 8 valence electrons, that's when you have that full outside shell of electrons and you're going to be stable. Okay. Give you a second to finish, right? We good? Okay, now related to the number of valence electrons is the kind of ion that elements will form. So if you are in this first group here, you're going to form a +1 cation. The reason for that is on the last slide, I said that everything in group 1 had 1 valence electron. So if I were to draw the Bohr model for lithium here, for just some sort of element in group 1, the Bohr model for lithium has 3 electrons, 2 go in the first shell, 1 goes in that second. If you're lithium or you're anything else in group 1, if you lose that 1 valence electron, then you would have a full first shell of electrons and you would be stable. That's why everything in group 1 forms a +1 cation. Going over to group 2, if you look at beryllium, beryllium has 4 valence electrons. Beryllium has 2 valence electrons. So beryllium wants to lose 2 of those valence electrons, then it would be stable. It would have a full first shell. If you lose 2 valence electrons, each electron's a -1 charge, that would give you a +2 charge. Keep going. If we go to, say, boron, boron has 3 valence electrons. So boron wants to lose 3 electrons, and then it would be have a full first shell. And so that gives it a +3 charge. Now something happens here. Once you go over to group 4, or group 14, and you get to carbon, carbon's got 4 valence electrons. So now what happens is they can be +4 or -4 because they could either gain 4 electrons, and that would give them a full shell, or they could lose 4 electrons. Neither is any more efficient than the other. It's like I have 2 doors here for the classroom. It's like if you're sitting at one of these middle tables, it doesn't really matter which door you go to. Each door is equally as close to you, or equally as far. That's what's going on here. That's why it's +4, -4. But now, once you get to group 15 here, now everything in group 15 has 5 valence electrons. Now they don't want to lose 5 electrons. They would rather gain 3. So in this scenario, it's more efficient to gain 1, 2, 3 more electrons to become a completely stable atom. And so if you gain 1, 2, 3 electrons, you would be a -3 anion. And that's the story that continues then for oxygen and fluorine, where you keep adding more valence electrons, so they would need only 2 and 1 more. Okay? So for ionic compounds, you got to understand what kind of ion these elements want to form. Put the cap on the wrong marker. Okay. So We said ionic compounds is when you have a metal and a nonmetal coming together. So in this example here, I'm showing you potassium sulfide. So in potassium sulfide, you have a potassium atom trying to pair up with a sulfur atom. Now potassium, here's potassium's Bohr model. Notice how potassium has just one valence electron. Okay? These potassium atoms, they would rather lose that one valence electron, because if they lose that one valence electron, then they would have a full outside shell of electrons. So potassium, each of these potassium atoms wants to form a +1 cation. Okay? Now if you look at sulfur, sulfur has 2, 4, 6 valence electrons. So sulfur wants to gain 1, 2 more electrons, then it'll be stable. So if you're sulfur and you want to pair up with potassium, you need to pair up with 2 potassiums to be completely stable, because you need to get 2 more electrons to have a full outside shell of electrons. That is why whenever you have anytime you have potassium, and when you have potassium sulfide, it's always going to be 2 potassiums for every 1 sulfur. It's not going to be 1 potassium for every 1 sulfur, because then those wouldn't be stable. Sulfur would still need 1 more electron. Okay? So the chemical formula here would be K2S, 2 potassiums for every 1 sulfur. So in other words, whenever we're making these ionic compounds, it's all about getting a neutral charge. It's all about what ratio, what combination of cations, things that make positive charges, and anions, things that make negative charges, do you have to get an overall charge of 0? That's the goal. Okay. So keeping it moving, let's look at another example. Let's say you have beryllium and nitrogen. So beryllium is in group 2. So in group 2, if you're in group 2, you form a +2 charge, a +2 cation. And nitrogen, it's in group 15, also called group 5. It forms a -3 charge. So as I said in the last slide, these, whenever beryllium and nitrogen come together, they have to add up to 0. That's when they're stable. So right now, if I had 1 beryllium and 1 nitrogen, this would be a +2 going to a -3. Does that equal 0? No. 2 minus 3 does not equal 0. So what you have to do is you have to adjust the number of berylliums and the number of nitrogens to get the overall compound to equal 0. For example, let's say hypothetically I was like, okay, well, what if we had 2 beryllium atoms? Well, that means you would have 2 +2 charges, each beryllium giving you a +2. So now 2 plus 2 is 4. -3, does that give you 0? No. Okay, so you're like, what if I add a second nitrogen atom? So you have a second -3 charge. So you have 4 -3 -3. That gives you what? 4 -3 -3. That would equal -2. Not 0. So we're still not okay. We got to get rid of a +2. Well, if I were to add a third beryllium, a third +2 charge, so if I had Be3, if I had 3 individual beryllium atoms, now this would be 2 + 2 + 2, that's 6, -3 -3, that would add up to 0. That's why beryllium nitride, it is 3 berylliums and 2 nitrogens. Because that's the ratio, that's the combination of berylliums and nitrogens you would need for it to add up to 0. Okay? Asking, like, so it's just, that's what's the most stable. It's like asking, why does a table have 4 legs? It's like, because if it had 3, it just wouldn't work. Like, it wouldn't be stable. Here, if you only had 2 berylliums and on, like, say, 1 nitrogen, it wouldn't add up to 0. It wouldn't be stable. Okay? Now, a shortcut here is whatever the charge is here, that's the number. Whatever the charge is here, that's the number of beryllium atoms you would need. Whatever the charge of the beryllium, that's the number of nitrogens you would need. Another way of saying that is whatever the charge is on the anion, that's how many cations you need. Whatever the charge is on the cation, that's how many anions you need. All right. We'll keep working on it. This is kind of for naming ionic compounds. This is sort of like a good summary slide on how you have to do it. Now, this is just part one, so there's some stuff here that you won't be using today. For example, this part here, don't cross this part off, but like this part here, we're gonna do this part and this part next class. All we're doing today is we're gonna just be focusing on how do you name things without something that has more than one possible charge, or without something that's like a polyatomic ion. I'll explain what polyatomic ions mean next class. So if you have an ionic compound, you always have the cation first and the anion second. So when we went over beryllium nitride, beryllium is your first atom. That makes the cation, the positive charge. Nitrogen comes second. That's your anion. So its name here would be, you say the name of the metal, beryllium, Be, and then N is nitrogen, but you don't say nitrogen, you drop the ending and you say I. So it's beryllium nitride. Okay? That's why if you look here, SrCl2, Sr is strontium, Cl, that's chlorine, but you don't say strontium chlorine, you say strontium chloride. If you look here, cobalt, Co, you would say cobalt. Ignore the -2. I'll explain why that's there next class. Cobalt with chlorine, you would say cobalt chloride. Okay? Let's try doing some practice ones. Let me write some on the board here. Let's say you had LiCl. What would be the name of that? This is the chemical formula when you just have the element symbols. What would be the chemical name? How would you name that? Lithium chloride. You would say lithium is your, you always put the metal or the cation first. So lithium is your metal. Lithium. And you don't say chlorine, you just say chloride. Okay. Now let's say we all right, I'll give you another one. Let's say we had CaO. What would that be? Calcium oxide. Calcium, that's the name of the metal here. Calcium, and that's, you don't say calcium oxygen, you say calcium oxide. Drop the ending and you put ide. So it's pretty straightforward when I give you the chemical formula how you say the name. What is typically trickier is if I do it the other way. If I do this, let's say I give you, let me make one up. Magnesium fluoride. So I give you the chemical name. What is the chemical formula there? I'll give you a second. Like, take a look at it. Try to think through how you would give the chemical formula. Just give me a second. So if you got magnesium, find magnesium on the periodic table. And if you look at magnesium on the periodic table, you know magnesium is Mg. That's its symbol. Then you have to ask yourself, well, what kind of ion does magnesium form? What charge of ion does it form? Positive, not 1, positive 2. Magnesium is in group 2. It forms a +2 cation. Okay, so there's a +2 charge there. Fluorine, what's its symbol? Well, fluorine is F. We'll then ask, what kind of ion does fluorine form? -1. It's going to form a -1 anion. Okay. These have to add up to 0. You've got to get it to a neutral charge. So as it stands right now, a positive 2 and a -1 doesn't add up to 0. So how would we get this to balance out to 0? Mars? Yeah, if you had a second -1 charge, that would add up to 0. How you get 2 -1 charges is having 2 fluorines. Each fluorine, like if I were to write this out, each fluorine has a -1 charge. That's why it's F2. That's why it would add up to 0. So that's why magnesium fluoride, its chemical formula is MgF2. Okay. Let's try to do another one. Let's say I give you. I'll go back to calcium oxide. Calcium oxide. Give yourself a minute. What would be the chemical formula for that? How would you write that? So first ask yourself, calcium, what's the symbol for calcium? Ca, right? Okay. What kind of ion does calcium form? +2. You know it's a +2 because it's in group 2. Everything in group 2 gives you a +2 charge. Oxygen, what is the symbol for oxygen? O. Okay. What kind of ion does oxygen form? -2. These have to add up to 0. 2 minus 2, does that give you 0?
Yes.
Yeah. Haley?
Is that how you write it, or you just
Oh, okay, yeah. So for the formative, you just write it as CaO. I'm writing the charges just so you can understand like why there's 2 Fs and here only like 1 calcium, 1 oxygen. But like in formative, if I ask what is the chemical formula for calcium oxide, you would say CaO. Yeah, yeah, sorry.
For the really good first is whether it had would it be like MgF2 like would we have to like change the tuning way of just
No, all right, yeah. So in the formative, when you type these in, so if you're gonna put MgF2 as an answer, having you put like subscripts in like that in the formative just makes the answers a lot harder to type in and longer. So just put it on the same line. Just go MgF2. Okay? But like you need to understand like if you were to actually like handwrite it, that 2 should be in the subscript. Okay? Let's do one more and then I'll let you start practicing with this. Did I have any more slides on here? This is another kind of summary slide. It's not a lot of these details here, like again, like this Roman numeral here. I'll explain why that's there next class. Basically, when you get the transition, when you do an ionic compound with the transition metals, it gets a little more complicated with how you name it. But yeah, so how you. Let me explain this diagram here. If I give you the compound formula, so these are the formulas here, like calcium chloride, the compound formula is made of a cation. For calcium chloride, the cation is calcium. For calcium chloride, the anion, that's chlorine, that's going to be your nonmetal. How you would say that name is calcium chloride, where you drop the ending and you put "ide." So the root is "ide." Here, this is saying the reason why there's 2 Cl's is because the cations and anions have to balance each other out. They got to add up to 0. Okay. And then the Roman numeral, if you have more than one possible charge. I'll explain that next class. But I just kind of want to start with this. Okay, so let me do one more example with you. Another one that's kind of, might say, a little trickier. Beryllium phosphide. What would be the chemical formula for beryllium phosphide? Take a look at that one. Try doing that one. Beryllium phosphide. Okay. So beryllium, find the symbol for beryllium. So it's Be. Okay. Beryllium is Be. Find the charge beryllium forms. So beryllium is in group 2, so it's going to form a +2 charge. And then phosphide, the I, that's the phos is talking about phosphorus, right? Okay, so phosphorus, that symbol is P. And the reason why I'm doing 2 different colors is just so you can, just help you see this is a cation, this is an anion. Okay? What kind of charge does phosphorus form?
-3.
-3, yeah. Now the charges have to add up to 0. So you need to adjust the number of berylliums, the number of phosphorus atoms to get that, yeah, sure, to get them to add up to 0. Star, I think you got it?
Yeah. What if you do beryllium and 2?
Yeah, 3 beryllium and 2 phosphorus. This kind of reminds me of like when you're doing like factoring and it's like which 2 numbers multiply to this number and add to this number, where there can be kind of some guess and check with it. You could, like how you could get the 3 and the 2, you could kind of guess a little bit and just play around with it. But the shortcut that will always work is whatever the charge is on the anion, that's how many cations you need. Whatever the charge is on the cation, that's how many anions you need. And just to be clear, the reason why there's 3 berylliums and 2 phosphoruses, if you have 3 positive 2 charges, is it phosphoruses or phosphori? That's a tough one. I don't know. And if you have 2 minus 3s, +2, +2, +2, -3, -3, that equals 0. That would give you +6, that would give you -6, that equals 0. And again, how you would actually write that is Be3P2. In other words, when you actually write the answer, you don't write the exponents there. I'm just showing the work there to see why it goes to 0. And then when you type that into formative, for example, you would just put it all on the same line. You would say Be3P2. That's a lot easier than messing with the subscripts, but you got to understand that technically that's going to be a subscript. Okay. Okay, the rest of the formative, it should be fairly straightforward. It's just kind of, I either give you the name, tell me the chemical formula, or I give you the chemical formula, tell me the name. So there you go. Let me know if you got questions, and I'll be walking around.